Alright, so in this lecture, I'm gonna go over the row interpretation of just the row interpretation of matrix multiplication. And say we have two matrices A and B that we multiply to get a matrix C. A is m by n matrix, B is n by p matrix, so C would be m by p matrix. And we write in detail this A matrix as this, B matrix is this, and C matrix as this. Now, for the row interpretation of this, what we'll have to do is work on this matrix and this matrix. So if you remember from the last lecture when we went over this is the column interpretation, where we worked on the first A matrix and C matrix. We converted this into columns, basically turned those column elements into single elements. And for both A and C, we did the same thing. Here, on the other hand, for the row, we would do it for matrix B and matrix C, but we will do it for the rows. We will turn each of these rows single elements. So let's do this the same way. So we will first let's color this up. So this is gonna be, say, 1. This is another 1, and this is the third, right? So let's first write this down. So this one, this guy is gonna be, so we write it as it is, but here for this next one, we are gonna turn these elements, these rows, into single elements. So we do this. So here we have B11, B12 until B1P. This is going to be converted into B1J. Similarly, the second one would be B2J. And the last one is going to be BNJ. All right, so let's color this again, color this up. So the first one is gonna be this, the second is gonna be this, and the third one was gonna be this. The last one is gonna be not the third one, the last one is gonna be this, because there are total n number of such rows here. And then as we go, like, we'll have to do the same for the resultant matrix. So this is going to be, again, let's color code this as well. So this is going to be one row, this is going to be another row, and finally this is going to be another row. Okay, so now this whole thing is going to be C1J. Let's make it another, so this varies from 1 to P. Oh, that's fine. And then this is gonna be C2J. This is gonna be CMJ. So, and then as we color code, so this is the first one, this is our second one, and this is our last one. All right, So now that we have this, we can express this in terms of the elements of the matrix C. We can express those in terms of the columns, in terms of the rows of matrix B. So our C1J is gonna be, so here one thing to notice is that, so the number of rows here for let me grab my pointer. So number of rows here is n, and number of columns here is n. So basically we multiply this with this, and then as we write it, we will get the first element, the first row of our resultant matrix. So it's gonna be A11 B1J, A12 B2J, A11N BNJ. Similarly, C2J is gonna be A21 B1J, A22 B2J, A2N BNJ. CMJ is gonna be AM1 B1J, AM1 B, this is gonna be AM2, gonna be B2J plus AMN BNJ. So this is how we get each of the rows of our resultant matrix by basically the combinations of the rows of matrix B. Again, so as we see this, so each element of this represents a row 1, this is row 2, and this is row M. So each of this row, for example the first row, is found by the combination of all these rows of matrix B, but the combination, the weight of the combination is determined by these elements from matrix A. Similarly, the second item is from the same rows but with different weight values that are determined, that are found from the from matrix A. So that's how we can write that. Similarly, like the column interpretation, we can write the rows of matrix C are combination of the rows of matrix B, while the elements along the rows of matrix A provide the weights. for the combination. All right, so this is the very basic thing about the definition of the row interpretation. Now let's go and jump into an example to see how we can utilize this method. So say we have A equal 1, 3, 5, 2, 4, 6. We have B equal 10, 20, 30, 40. 1, 2, 3, 4. The question is C is equal to what? So we can see that this is a 3 by 2 matrix, and this is a 2 by 4 matrix. So basically that will result in a 3 by 4 matrix. We know that beforehand, but we will need to solve it using the row interpretation. So let's write this down. A, B equal 1, 2, 3, 4, 5, 6. Multiplied by 10, 20, 30, 40, 1, 2, 3, 4. So since this is our B matrix, we're going to turn this the rows into single element. This is the first step. So we keep this matrix as it is, the A matrix as it is. So 4, 6, and then we convert it into basically one matrix. So this is, say, if this is R1, this is, say, R2. And then what we do, we basically write this down. So the first element is gonna be R1 plus four R2 not 4, this is gonna be 2 R2 3 R1 plus 4 R2 4 R1 plus 6 R2. Right, so this is gonna be how it should look like. Let's do like this. So this is gonna be our C1, our C2, our C3. And our R1 is this whole thing, which is 10, 20, 30, 40. And R2 is this is gonna be 2, 2, 4, 6, 8. 2, 4, 6, 8. Two, 4, 6, 8. and then as we sum them up, we get 12, 24, 36, 48. This is our first column, first row, and the second row is gonna be 3 multiplied by this guy, which is becoming 30, 60, 90, 120, and 4 means 4, 8, 12, 16, which gives us 34, 68, 102, 136. And then the last one is it's 4 times, so 40, 80, 120, 160, and 6 times this one, so 6, 12, 18, 24, and this becomes 46, 92, 138, 184. So this is what it looks like. Let me check if I have done it properly. So 6 into, so 4 by 4, 160. Alright, I have made a small mistake here. It should be 5. So if it's 5, then what does it become? Let me double check this thing. 12, 24, 36, 48, 34, 60, 68, 102, 136. So let's multiply by 5. So it becomes 50, and this is 100. This is 150, and then 200. So this becomes 56, is 112. This is 168, and finally this is 224. Alright, so we have this R1, R2, R3, and that's what is our C. Our C matrix is nothing but R1C, R2C, R3C, which is gonna be the first one, 12, 24, 36, 48, 34, 68, 102, 136, 56, 112, 168, 224. So this is gonna be our answer. That's how we can multiply two matrices using the row interpretation, and it often gets easier